3, 2, 1, fire. Hey, it's me, Destin. Welcome back to Smarter Every Day. I am at the American Museum of Natural History, I think it's called. It's the Smithsonian Museum. And this is something that I saw 10 years ago, and it changed the way I think about bullets and ballistics and probability and things like that. It's 2 bullets from the Civil War that met nose on. Check this out. It's poorly lit, so I'm gonna have to turn my phone light on here. Okay, I don't know if you can see this. So these 2 mini ball bullets met nose to nose. The plaque here says in Fredericksburg in December 1862. So let me see if I can manage the glare here, but look at that. 2 perfectly aligned bullets. Now the interesting thing is this is not a glancing blow, like total momentum transfer between the 2. So you have a bullet go in one direction, a bullet go in the other direction, and they hit and they stop perfectly. I've seen many attempts to try to reproduce this, but they all fail. I'm gonna try this today. It's gonna take a little engineering, but let's give it a shot. I've actually had some internal conflict about doing this video because internet video has become, sensational and spectacular. The moment I visualized in my head a bullet hitting another bullet, and I thought about all the camera angles, I'm like, I have to make the video, but I want to do it in an intelligent, respectful way that doesn't feel like, I'm trying to win the internet. I just want to see this, and I want to take you along with me. So I want us to think together about how we're going to do the safety side of this. That being said, please never do this. I worked for 15 years as a missile flight test engineer, and I had mentors that slowly walked me through the safety processes, and I made mistakes and they corrected me, and they were always watching over my shoulder. So I'm not just some guy trying to do a complicated thing. I've done far more complicated things like this with larger groups of people, and we did it in a safe way. And the way we did that is intellectual humility. So we're gonna have an atmosphere of intellectual humility about this. Let's get started talking about what we have to do. If we're gonna hit a bullet with a bullet like this, we have to have guns, right? So we have 2 empty guns. If I go over here and I set up this gun right here, I have to aim it so that a bullet goes right here in the middle, right? And I have to point another gun from this side, and the problem is me over there with that gun is in the firing path of this gun. So we have a problem here, right? Okay, let's say you figure out how to hold the guns. You got to think about other things, right? Let's say we load this gun. How do we go load this one safely? Because we're downrange from that one, right? How do we pull the triggers? That's a thing. And once we do, we have all these mechanical inconsistencies because these things are not repeatable in terms of timing, which means those bullets might not meet right here in the middle where we line in that high-speed camera. It could be here, it could be here. What happens if this bullet misses? Is this bullet going to destroy this gun? All this stuff means we have to over-engineer this. So there were 4 of us involved in the design of this whole thing. First of all, my buddy Ernie. He's excellent at electronic design. He's got years of experience designing circuitry for explosive systems. You may recognize Jeremy Fielding. He's an excellent educator. He's a fantastic mechanical designer, and he engineers all kinds of crazy contraptions. Jeremy helped design the safety shielding. He also worked on a neat contraption I'll show you in a minute. Then there's my buddy David, a mechanical designer who you may recognize from the Vortex Collision episode. He's really good at everything he does. He also reloads ammunition as a hobby, so this was a perfect fit for his skill set. We slowly worked on this project in the background for years. In fact, we even used the shield as a part of the supersonic baseball cannon video. Modern ammunition is quite different than Civil War ammunition, so we decided on the 45 long Colt cartridge for this experiment. There's several reasons for that. It's a straight wall cartridge, it's very easy to design around, and it looks old, kind of like a Civil War bullet. We considered molding our own bullets using an authentic Civil War bullet mold, but ultimately, this stuff was so easy to get, we went with 45 long Colt. It's time. Finally doing the video I've been wanting to do for a long time. This is the spotted dirt for many reasons. Number 1, it's a bowl. So if the bullet misses this way, it'll go into the dirt. If it misses this way, it'll go into the dirt. The sun's up there. And then this is the thing that we've been waiting on right here. What do you think about this piece of dirt right here? Down in the little spot. Yeah. First thing you do when you do a test like this is you have to establish the center of the earth. I declare this the center of the earth, right here. We made this big I-beam. This is our datum. We're gonna assume it's rigid and everything is measured from it. Once we got that in position, it was time to grab the gun. This thing's heavy. Well, this feels like a moment. These are the simplest guns we could possibly make. They're very special, and we'll talk about that in a minute, but first we have to bolt them to the I-beam. Before we dive into how these things work, let's take a second and look at the mechanics of how a normal gun works. With a mechanical firearm, you have something called lock time. Now I've got the high-speed camera set up right here, and I'm gonna set the camera up here. I'm gonna go get the high-speed camera trigger and the pistol. Lock time is how long it takes the mechanical hammer to fall and strike the firing pin, and the firing pin to engage the percussion primer that's on the back of a bullet. David, am I clear to load?
Go ahead.
And I'm gonna get a high-speed camera shot of it when it happens. You ready, David?
Ready.
All right, 3, 2, 1. You'll notice that it takes time for the spring down in the handle to accelerate the hammer towards the primer. That's called the lock time. From the moment you pull the trigger to the moment the primer is struck, that's the lock time. Everything after that is the bullet dwell time, how long it takes to ignite the primer and for that to ignite the powder and for the bullet to exit. So most weapons have about a 10 millisecond or less lock time. In our case, we're gonna hit a bullet versus a bullet. So we can't control the dwell time. It's gonna ignite the powder however long that takes. But what we can control is the lock time. And the way we do that is replace that mechanical trigger system with an electrical trigger system. In fact, we replace the mechanical primer with an electrical primer. All right, so this is how this thing works. So this is the gun, and it's just a barrel. That's all it is, off the shelf barrel. And this is the breech. So the bullet goes right here, goes right in there like that. This right here hooks up right here. So we have a positive side and a negative side, so the whole thing is grounded. We have a stationary plate on the bottom, and you adjust these screws right here to change azimuth left and right. We're pivoting around this point right here. David, what would you say about the elevation technique here? This is
Primitive stuff we had laying around.
just a jam screw. Okay, so how do you load a bullet and then load another bullet without being downstream of the first bullet? Well, I drew something on a napkin. My buddy Jeremy Fielding has a CNC plasma, and so he helped make this. He designed this. We talked about how to do it. All right, go ahead and unblock the first gun. Yeah. Cool, right? I know, right? Okay, so basically it's an ellipse here and a piece of steel that can take the impact of a bullet. And the idea is we come back here and we load one bullet, we put the breech on. You can close this one, we block it, and then once we block it, you see that bullet would impact there. And so any fragments from the bullet would go that way. I like it way more than I thought I would, dude. It's amazing. Okay. The engineering is done. It's time for procedures, which is extremely important. Yes, we have a really cool blocker system, but that's not going to keep us safe if we don't use it correctly. So what I did at this point is I created a checklist that goes into painstaking detail about how these things should be done. And more importantly, I drew up these stick figure drawings to try to explain to myself how everything could be done safely. I'm not going to show you all the safety measures here. There's so much that went into this. Circuitry, voltages, all these things. But if there's anything I've learned over the past many years doing dangerous things, the moment I start to think I've got it figured out is the moment I get myself into trouble. So at this point, I knew it was extremely important to get other experienced individuals involved so that they could critique what I've done so that I could stay safe. The advantage of living in Huntsville is that you got buddies that test explosives and they know what's up. This is Sheldon, this is Coop. We're gonna do a safety checklist, and they're gonna tell me what I did wrong. And they're probably gonna, you gonna be mean or nice?
Mean.
Mean. All right, let's go for it. These men are world-class subject matter experts, and conversations like this are one of my favorite things to do. They made suggestions and corrections which were obvious as soon as they said it, and that's why I love doing this.
When you approach the south gun to remove the breech, I was just say you could
disconnect first?
Disconnect first.
Write it down. Let's do it. So where would that go?
Between 3 and 4.
Well, I'm thinking if you got a hang fire on this one, and that one's fine.
Yeah.
I'm assuming that one's probably fired, and this one isn't fired then, so you wouldn't have that issue.
So if the high-speed camera, for example, says this one fires.
Yeah, there's still potential for it to fire this way if you're on this side of that shield with it open.
Yes. So I need a misfire procedure for each possible.
Yeah.
Okay. Yes, you're right. This is helpful, thank you. Get smart people in your life who love you enough to smile and tell you you're wrong. Okay, first shot. We started off by testing each gun independently to make sure all the hardware worked and to make sure our checklist ran smoothly. Verify there's no voltage. 3, 2, 1, fire. Our idea was to shoot at a piece of foam board and then align both guns to the same point in space. We also wanted to test our background colors to see what would work best for the high-speed camera. All right, I vote we just go for it.
You want to go look and see where these holes are, though?
Okay, that makes sense.
Okay. I'm pretty sure from
You're
here.
making sense, David. Okay.
Yeah, they're significantly off.
Oh, God. Not crazy. That's the same hole.
Oh, is it? Okay.
Yeah.
Yeah, I was looking at the scrap paper there.
Once we looked at the holes, we realized that they were a little bit off, so we got a laser to make some adjustments. We decided not to move the north gun, it was going to be our datum, and we decided to move the south gun so that the holes would align and the bullets would hopefully intercept. So here we go. It took years to get to this moment. 2 bullets.
2 bullets.
I'm gonna do stray voltage over here. Stray voltage check is good here. Stray voltage check is good. You undercover?
Yeah. I'm good.
Loading the north gun. All right, block the north gun. It's good.
Okay.
Loading the south gun. We lost all of our light. All right, unblock. Here's the arm plug.
Armed.
Ready?
When you are.
3, 2, 1, fire. I felt fragments over here. Did you hear it?
Uh-uh.
It happened. We're about to see, this is about to happen. I felt fragments. I didn't feel them, but I
Yeah, I was gonna say.
I
you wanna
heard them.
elaborate on that?
Yeah, I mean, we're about to see a bullet impact a bullet. David, I think this has just happened. Ooh, okay. Wow. All right. Heart beating faster than expected. Whatever it is, this is gonna be something to build on. Okay, so those are bullet fragments. Look at that.
That was only like 5 or 6 inches to the right of center, wasn't it?
Oh, David, we know what we're doing now. Oh, dude.
It's pretty dramatic.
Yeah. Third time's the charm, David. We did it on the third shot.
You could almost say it was on the first shot.
Yeah, it's the first time we tried it. There was this little feeling inside, like, did we really just do it? Like, maybe we can skip the part of the video where we struggle to figure it out because we just did it on the first time because we're so good. No, we're not. You'll see that in a minute. Another thing to think about is those bullets exploded, which is amazing and all, but that's not what we're trying to do. We're trying to fuse them together like the Civil War bullets in the museum. So what do? My answer to this is to zoom in and try to get a better feel for what's going on. To do that, we need to move the slow motion camera closer, and I need the lowest exposure time possible and the highest frame rate possible. And I decided to make what's called a fiducial. This is a measuring stick of sorts, and I decided to put SmarterEveryDay on it because a lot of times people steal slow motion footage like this, and I just thought it would be great to be able to measure the velocity of the bullet. And if it says SmarterEveryDay, like a physical watermark of sorts, at least people will know that they're doing something wrong when they steal the footage. So my goal at this point was to get as tight and as fast as possible and to just see if we could understand the phenomenon that's going on. 3, 2, 1, fire.
Only saw smoke on the left side.
Yep. We had a misfire. Only the south gun fired. It's a good thing we thought about misfire procedures because we used them immediately. Clear, it's all clear. 3, 2, 1, go. I heard a big old piece of bullet come back here that time. Did you feel it? Three, 2, 1, fire. Maybe we got too confident. At this point, we got frustrated. We started missing things several times and we didn't know why. We thought it might be vibration of the gun, so we turned the high-speed camera over and tried to analyze it. We started looking at every variable we could find. Sometimes it would miss and sometimes it would hit. It was a combination of timing and aiming. So our shots are inconsistent and we've got to address what's going on. And you're probably wondering why we haven't destroyed the other gun yet. The guns are offset by about 1 degree. That's certainly played in our favor on all these misfires. We haven't damaged the other gun yet. The next thing to think about is how much powder is in the cartridge. This is the 45 long Colt cartridge that we talked about earlier, right? We have powder in this thing, but we don't want too much because we don't want it to be too fast. So David and I purchased some of these shorter brass cartridges so that we could fill them all the way up with powder. To understand why we did this, let's 3D print a section of our barrel, and I've got some split cartridges here, and let's fill them up with gunpowder. Okay, look at this. So we've got the long cartridge on the left, and we've got the short cartridge on the right. This is roughly the same amount of powder, and you'll notice that the cartridge on the right, the shorter one, is full. We did this because we want a consistent velocity, and the assumption is when you go to load that longer bullet inside the gun, you can see how that powder slumps down in the cartridge. It's not filling up the entire volume, and the thought is we would get an inconsistent burn. There's one thing about this though. If you look really, really close, you'll notice that way up here up front, that bullet is engaging the riflings. The riflings are the thing in the barrel that spin. They're these grooves that spin the bullet as it goes down the barrel, and that bullet right there is already engaging the riflings. So we've got two things going on. We have a gap in our powder, but we are engaging the riflings. The short cartridge, this is something that we think might be giving us a problem. If you look really close here, yes, the powder is more consistent. There's no slump of the powder, but there's a gap between the front of the bullet and the back of the riflings. So the thought is that bullet is having to jump the gap whenever you fire the bullet. And sometimes we can even see it on the high speed. We can see a fireball come out before the bullet, which tells us fire is getting through that little gap right there, and we think that's giving us inconsistent velocity. All this is so hard. You can see why there's so many variables here, but even in the edit, when we started looking at all the shots in really close detail, we noticed that on the north gun, which was our datum, there's a nut on the elevation control of that gun that would move during the firings. So we were trying to aim to something that was moving. We have so many variables here, but it's okay because eventually we figured out that the long cartridges work better, and we got into a rhythm and we started actually getting some hits. One of the most beautiful things to me about these intercepts is when the bullets come in and collide, depending on where the noses are, the tangent points define a plane of fragmentation. And so like if this one is high and this one's low, then the angle of the fragments will be like that. If this one's left versus right, it's going to just change and make a three-dimensional plane defined by where the tangent points touch each other. It's beautiful. So everything's working and now we get to play. We're seeing the high-speed camera view right there, like 90 degrees to the flight axes of the bullets, right? What happens if we rotate it around isometric like this? What happens to the back of the bullet? We're gonna get to see that if we put the high-speed camera in just a little bit more danger than from the side. Let's go see what it looks like. That last shot you saw was a hollow point bullet, which is why it exploded in such a crazy way. We've mostly been firing normal lead bullets and full metal jacket, which is just a copper sheath on the outside of a lead bullet. In this next shot, we were firing full metal jacket bullets against each other, and something incredible happened. 3, 2, 1, fire.
I think I saw him hit.
You saw him hit?
I did.
Awesome. But you could see it? How does that work?
Oh, wow.
It stopped! It just stopped. You see it?
Maybe that's why I saw something. It hung in the air.
It hung in the air. Oh man, that was a perfect momentum transfer. That is as close as we've gotten to make them fused. It's like you froze it there. We can find the tip of that thing. It would have been to the left. Is this it? That might be one of the back ends. Yeah, this is it, Dave.
Is it? Okay.
It looks just like the other one. Yeah, these are them, Dave. Look, you can see there's a little circle where the nose of the bullet was, where they met. You see that? Mm-hmm. So there's a little piece of copper that was in between those, like a little circle of copper. Actually, 2 circles of copper. Oh, I wonder if the other camera will show us.
Which way it went?
Yeah.
We never did look at that, did we?
Yeah, I'm still waiting on the big file to save. That is that guy. You see it? That is that guy.
How about that? What's the odds of finding this?
Oh man, which means, where are you? It's straight in plane with the camera. So I'm gonna get right here at the intercept point. I'm gonna look right back at the camera, and it's like on this line right here. Just a little bit to the left. You got it! Yes!
Boy, that's tiny.
Oh, yeah! That's awesome! Is it got copper on both sides? Yes!
So is that the tip?
That's it. So that should go in between our other two pieces. Let's see if we can put these together. That looks like it to me. Can you slide the other one on top of it? Like that right there.
I would guess.
That is like the coolest thing ever, man. That's,
Not quite a fusion, but almost.
God, that's
The
awesome.
fact there's copper on both sides of that meant that was from the collision, I guess.
There's copper on both sides. Yeah, that means that's one copper node. But what's happening with the lead? Yeah, I don't know, man. I just know it makes me really excited. It is so cool that you said you saw that one.
Yeah, I
That
saw
means-
that collision.
That means that long video, that long lens should be able to see it too. If we replay
Probably
that long
so.
lens, we could see it. I'm jealous you saw it with your naked eye.
Wish I can just only describe it to you.
Please, David, describe it.
You would have had to have been there.
So all this work, and we still haven't fused two bullets together. Our assumption is it's because we're firing the bullets too fast, and our lead is not the same type of lead used in the Civil War. So what we decided to do is the only thing we had within our control, which is load super slow bullets. We hand-loaded more bullets with the least amount of powder we thought possible and still make it down the barrel, and this is what happened. One, fire. Boy, those things just barely flew. Here it is. We may have a squib on the other side, meaning it didn't exit the barrel. Okay, misfire procedures. It's right at the end. That's the bullet. Can you knock it out? Oh, man. So clearly that wasn't enough gunpowder, so we loaded just a little bit more and gave it a couple of more shots. Fire. Okay, it didn't explode as much. You see that? So close. It's our lead, David. They want to stick together so bad, but they refuse to. All right, so it looks like we cannot make these things fuse together with the lead that we made these bullets out of and purchased the bullets from. So I think we need to figure out a way to shoot them slower, to mimic terminal velocity more, and we also need to change the metal composition. But for now, I have something else to show you that's pretty fun. I may have accidentally shot the coolest ad I've ever made on Smarter Everyday, and I'm excited to share that with you. It's for Ridge Wallet. This episode of Smarter Everyday is sponsored by Ridge Wallet. So Ridge reached out and they're like, hey, we want to sponsor Smarter Everyday. And I said, no, I'm cool with my leather wallet. I don't need to change. They're like, that's cool, no big deal. We're just gonna mail you one anyway. One day, I'm walking around the house and I look at that thing, I'm like, that thing, I should try that. I should just know that I don't like it. And so I put my cards in it and I put it in my front pocket and I love it. I genuinely love it. This is the old man part that I'm afraid to say, but my lower back pain went away, and I'm ashamed to tell you that, but that actually happened. So anyway, I called Ridge back. I was like, hey, will you please reconsider? I'm sorry, we broke up. Will you please reconsider sponsoring Smarter Every Day? And they were like, sure. And then I made this video, and then something amazing happened. I ended up shooting a really, really cool promotion for Ridge. They have a lot of different materials. They have Damascus steel, which looks like that. They have titanium, which looks like that, and they have aluminum, which looks like that. There's a story there. This was my actual wallet, and this is what I want to tell you. I asked Ridge if I could give you this. It's an AirTag money clip, and it is the most amazing thing. I can find my wallet in my house using an AirTag, and I asked them if I could give you a free AirTag money clip if people go to ridge.com/smarter and they get a Ridge wallet. I said, can we throw in a money clip for free? And they said, we don't do that. I said, you must do this because it's that amazing. And they said, yes. So if you want to try this, I promise you're gonna love this wallet. Go to ridge.com/smarter and you get to tag on an AirTag money clip to your order. They have a 99-day, you try it and you can give it back, money back guarantee. That tells you how good it is. And by the way, backed by a lifetime warranty. These make fantastic gifts for your dad. They've got a Father's Day sale going on right now where there's ways you can get up to 40% off. That's a big sale. Go to ridge.com/smarter. It's a genuinely good wallet. I only talk about things on Smarter Every Day that I genuinely love, and you know if I'm telling the truth, and I am, and I want you to have an AirTag money clip. Go to ridge.com/smarter and let's shoot these things and let me show you how they work. We thought it would be fun to shoot these wallets from both sides because they're two plates of metal. The first one we decided to shoot was the Damascus steel version because it sounds like the toughest and we wanted to see what happens.
It's gone.
I heard something big land in the woods. Turns out the bullets didn't fire at the same time, which I think made it even more awesome. Oh man! Oh, that is so cool.
Did that go through?
It did not penetrate. Next up was the titanium wallet, and this time the bullets fired at the same time. For the last shot, we wanted to fire against lightweight aluminum, so we used my actual wallet because I've had my eye on a new blue one, and this was a good excuse to make the changeover. What happened here was surprising. Firing against my wallet in 3, 2, 1, fire. Oh, it went through! This was aluminum. This was an aluminum wallet. Was that 1 or 2?
Can't tell for sure, but the wallet's still in place.
Shut up.
What do you get?
Is the bullet... What just happened?
Looks like that bullet fell straight down.
It did. It's gonna be right there on the ground. How crazy is this? It's right at the bottom, under the tripod. Didn't even have to move. Please focus. Here you go. Is that 1 or 2 bullets?
Ah. I think that's a possibility. That may be more than 1 bullet.
That might be both of them. There's a tiny bit in the back. That's heavier than...
This feels heavier than...
I wonder, now this is stupid, I wonder if the aluminum slowed them down just enough so they would fuse. We still get the fragmentation on the edges. You see that? Mm-hmm. And then look at that, it's absorbing it. And it's not letting it leave. Like it's holding it. And maybe even that AirTag thing contained it. It almost stayed. There's just a little piece of bullet leaving. Okay, we have my wallet, an unfired bullet, and the bullet we pulled out of that. Bullet first. Digital scale. 14 grams. Okay. What about the thing we pulled out? 22 grams. We had a partial fusion inside the wallet, and I have decided it doesn't count. I love doing this so much. Thank you to everyone who supports on Patreon. You help me do this. It takes years to do a project like this, and I'm grateful to everyone who supports at patreon.com/SmarterEveryday. This is not over. We have ideas. We're going to, well, I'm not going to tell you what we're going to do. We just have ideas, and we're going to try to figure this out. So if you would consider supporting at Patreon, I do a few things. Everybody gets a baseball when they sign up there. And also every year we have what we call a sticker team for people that stick with me. The first year was the Supersonic Baseball team. The second year we had the James Webb Space Telescope. That was a holographic sticker. That was amazing. I'm thinking this year we should have some kind of bullet versus bullet team or something like that. So if you want to consider sticking with me, you can do that at patreon.com/SmarterEveryday. Also, there's an email list if you want to check that out. I promise I won't spam you. I'll just tell you when I upload new videos, and I'll leave a link down below for that. Anyway, I'm grateful to everyone who watches this stuff. I would do this, like, again, even if internet video wasn't a thing. This is what I love doing, and I'm grateful that you're here. I'm grateful that you're consuming this content that me and my buddies spend so much time building. We're grateful. Anyway, I'm Destin. Thank you so much. Getting smarter every day. Have a good one. Bye.